Good afternoon, ladies and gentlemen. Welcome to Techgig webinar series, our endeavor to empower techies. We believe that sharing of knowledge is the key to enhance our skills and grow us as professionals. With this principle in mind, we have initiated a series of webinars conducted by industry experts to give you all a crisp insight of various domains. The topic of today's session is Emerging Trends in Software Testing 2012. Our guest speaker today is Dr. Vimla Ravishankar, Senior Application Specialist at Bioanalytical Technologies. Vimla works in an organization which specializes in custom software development, serving the niche areas of life sciences healthcare industry. She is involved in all stages of the development, right from requirement scoping, analysis, creation of functional specification documents, getting it approved from the client. She is also involved in activities like test case creation, bug reporting, tracking the bug life cycle, verification and validation, test planning, gap analysis, performance testing, training, etc. So without further delay, I introduce you all to our guest speaker, Dr. Vimla Ravishankar. Over to you, Dr. Vimla Ravishankar. Yeah, Vimla, can you hear me?
Yes, I can. So, should I start?
Yes, please.
This is Vimla Ravishankar. I'll be talking about, like Garima said, on emerging software trends in 2012 and for that introduction. And we'll begin right away. Emerging trends in software testing. So, software testing, a typical picture that most of us know about bugs, looking for bugs or, defects in the software. If you look at the typical definition on the web or in any textbook or article, the typical definition is, what is testing? Testing is the procedure done to identify that a software works as anticipated, it meets the requirements on which the implementation was done, it has no major defects, and it satisfies the needs of the definition of software test. Well, usually, I'm talking about the early period when software was, being developed. So testing at the time was the last activity performed after development was done and before release in the waterfall model. It was many a times a rushed activity which was squeezed in available time frame after coding was done and just before the release. And it usually came into a project late. It contributed little in terms of quality because sometimes there was not enough time to test it thoroughly, and it was very expensive because some of the bugs would get away and then they had to be fixed on later. So coming to the facts and figures about testing, more than 50 billion per year are spent on application testing and quality reports. These are reports by PAC, that is peer audience consultants. Spending expected to increase to about 19.3 billion on testing services alone by 2015. These are figures by IDC and Forrester. 91% of IT decision makers consider software testing and IT quality management to be among the most important IT tasks, again by PAC consultants. If we look at the actual, figures, facts, figures as in cost of defect fixing, as you can see, requirements, design, coding, testing, and maintenance. So the later in the life cycle you go, the steeper is the graph indicating the cost. In the testing phase itself, it costs around $8,000, $7,000. In the maintenance phase, it goes sky high, around $14,000. So as you can see, the earlier that we fix the defects, the easier it is going to be for everyone in terms of money, in terms of manpower and efforts that are put in by everyone. Again, a different view of the same thing. So software development stage, it costs 1x, and then these, of course, 30 times. What are the recent trends now? So as we have progressed in the IT field, or as technology has progressed, testing now has become a planned methodical activity. It is not done only at the end, after the coding is complete, but at each stage of the development. New technologies, cloud computing, web applications, smartphones, stricter regulations have given rise to a whole new world of testing. And some of these trends that are catching up are discussed in the following slides. So what I've tried to do is give an overview of some of the more popular techniques or trends that are catching up, and how they started, the general scope, the advantages and the disadvantages, and the tools that are used. So what are the recent trends in software testing, very development. So as all of us are aware, all of smartphones have been rapidly replacing our cell phones. So we have Androids and iPods and iPads replacing our regular normal telephone. And all of us are depending more and more on our smartphones to carry out our everyday tasks, be it internet banking or communication, of course, and then photographs and whatnot. And the factors for mobile application testing, what would they be? It would include security, stability across a wide range of operating systems, because different carriers or different manufacturers have different operating systems. And then you have, hardware and the software to take care of. So it must be done on both the software as well as the hardware, the testing. And it's not easy. Why? Because it involves a lot of, testing applications across a wide range of handsets and the languages. You have different carriers or manufacturers, and then different locations to take care of. And tools for testing are available. They are emulators and simulators. So emulators and simulators, what are they? We just have a look at that. Emulator is a piece of hardware used for tests. It is independent. It can be linked to a development environment. And what is a simulator? It is a piece of software with which a code can be run to see that it runs correctly. Emulators mimic the software as well as the hardware environment found on the actual mobile devices, simulate software environment. So depending on what you want to do or how comfortable you are, as a tester, one can take the emulator to test the application or a simulator to do that. An overview for mobile application testing. Here we have the operating system perspective here, the compatibility, iPhone, Android, Blackberries, Windows. And then here you have the hardware perspective, compatibility, interoperability, automation testing, end user is usability, performance, stress testing, reliability, and then you have all the others, internationalization, local languages being supported, and the others in general you have general communication, testing data exchange and synchronization testing. Because we tend to do a lot of things, messages. Types of mobile testing, again, a detailed overview of each of those. So we begin with functional testing. What is functional testing? It ensures, as the term suggests, that the application is working as defined in the requirements. Testing, this type of testing, the user interface and call flows, how it flows in that particular handset or mobile. laboratory testing. It is carried out by the network carriers. It is done by simulating the complete wireless network. And why is this done? So that, to find out if there are any glitches when a mobile application uses voice and data connection to carry out some of the functions. The other type is memory leakage testing. It occurs when an application is unable to manage the memory it is allocated. And if you run out of memory, what happens? Resulting in poor performance of the application, and there's an overall slowdown of the system. As mobile devices have significant constraints of available memory, this type of testing is important to see what are the tasks that can be, allocated within a certain memory limit. Interrupt testing, again, as the term suggests, an application while functioning can face several interruptions like incoming call, outage, area, recovery. So an application should be able to withstand all that and handle these interruptions. How? It should go into a suspended state and then resume afterwards once the glitch is over, or it comes out of the outage area or coverage area. Usability testing, this is crucial for the manufacturers because it would determine if the application is getting a favorable response from the end users, and this would be the key to commercial success for any device. Installation testing, not all mobile sets come with pre-installed applications. So what you have to do is install. So installation testing, it verifies that the installation progress goes smoothly without any difficulty, and this typically covers installation from the store, updating, and uninstallation of the application. Certification testing, again, each mobile has to be certified, and so again certain guidelines which are set by different government organizations or regulatory bodies. So this type of testing makes sure that your certification or compliance certificate, your mobile behaves or is in compliance to get a compliance certificate. Tools that are available for mobile application testing, you have Android, Google Android, .mobi emulator, iPhone, BlackBerry simulator, iPad, iPhone, W3C, OK Checker. These are just some of the tools that are listed. There are obviously a lot more in the market, and new tools are coming up every single day. Now coming to the challenges faced by mobile testers, testing across various OS platforms, then different handsets. All of us are aware there are millions of models available. So as a tester, you have to make sure that each set passes the guidelines that are set. Then languages across the world, there are millions of languages, so it has to be supported for that particular area at least. And then security is the big concern because you have personal data that is being passed along. So you have identity thefts that can happen or data that can be hacked. So security is an issue and a challenge. Data integrity, again related to security in a way, because a lot of data across back and forth worldwide. Coming to the next emerging technology, that is test-driven development, known as TDD. Test-driven development, or TDD as it is more formally or popular. Kent Beck was the one who discovered it in 2003. It is not exactly a new technique, but it is gaining importance. And why? Because it ensures that the source code is thoroughly unit tested. As many of us are aware that unit testing is not always done in the scheme of things. It's like, okay, let's get this done and test it by the testers. So in that kind of scenario, it is quite possible that quite a few bugs get away. So this test makes sure that each source code piece is unit tested, and it allows an incremental methodology. That is, you do a piece, test it, and go to the next piece. You don't just keep coding till the end and then say, okay, where did I go wrong? How do I fix it? So it allows an incremental methodology, and defects are detected and fixed as soon as the code is written and not at the end of the iteration cycle or milestone, which normally used to happen earlier. In traditional methods, unit testing is not strictly enforced, like I mentioned earlier, but in test-driven development, testing drives the coding and the software cycle and ensures that unit testing is done. Test-driven development, this is a very typical flow. So you first, what do? You first write a test, and that test should fail. Why should it fail? So that you know that how to go ahead and how to go ahead properly. So then once it fails, you know, okay, how to make it. And once that is done, you write a production code, and then again go on adding, and then you run all your tests. And after all the tests are succeeded, you know, you clean up the code or you do refactoring. This is also known as, I've come across some terms like traffic coding. Why? Because it uses red, yellow, and green. Red for, the flow. So red, why red? Because you write a test that does not work. And then yellow, what do? You make it work. You can mess it up here if you want to make sure that it works. And then going ahead for green, what do? You refactor. That is, you clean up the mess that you may have created to make it work. There are, coming to the levels of TDD, there are two levels of TDD. You have acceptance TDD or ATDD as it is known, where the writer writes a single acceptance test and the code is written to execute that particular test. And the aim here of ATDD is to specify the requirements. Most of the time what happens is requirements are just documents like FSDs or FRS or USDs, and the coding people read the document like a Bible and then try to interpret it. So what can happen is, sometimes reading between the lines and among the lines can cause errors, as all of us are aware, and lead to, implementing a function which is not exactly what is required by the client or the customer. So the aim here, since you write a test and make sure that the test passes and then write the code, you specify the requirements in a better way than just documenting them in an FSD or a URS. The second level is the developer TDD. Here you write a single developer test and then just enough production code to fulfill that particular test. So again, you don't go from start to finish trying to, end the whole cycle there. The goal here of the developer is to specify a detailed executable design for your solution on a just-in-time basis. Again, timing being crucial, so you have everything done just the right way in the right time. Developer TDD is often called just a TDD, and the aim here is to specify a detailed design. The tools used here, JUnit for Java, Google Test, you have HTML unit, you have a CS unit for .NET, you have a VB unit. And of course, lots of others, I'll just mention a few. The advantages here, detailed testing, because you go step by step. You have clean coding because you do refactoring. And in the first place, your test drives your coding. So you know exactly what you have to write to make the test pass. And then you develop high quality code in less time. The disadvantages, this is not useful for databases and for large functionalities where you need to, write a huge piece of code. And again, this is useful for legacy ongoing, and if you try to add something to an existing one, obviously this won't be very useful. So that is one of the disadvantages of legacy, not supporting legacy applications. The next one that we come to now is testing as a service, and TaaS, and this is also cloud computing, as most of us know. Cloud computing is an internet-based solution. It provides on-demand testing services on the cloud to third-party clients. This can be done, 24/7, 365, no time constraints, no, date constraints. And Harvey is the person who first suggested computer time sharing technology. Way back in, 60s, 70s, he said that, there would be a time when computing power and even specific applications could be sold through utility business models, much like, water or electricity. And shared resources, software, and information are provided to computers and devices on demand. And it provides testing capabilities to end users. It offers a platform, that is testing as a service, offers a platform to utilize shared resources in a pay-as-you-go model. And why is this catching up, cloud testing or testing as a service? Because, limited test budget for organizations, meeting deadlines, and then high cost per test. We just saw the cost for, defect fixing. There are large number of test cases, which are of little use. Once you write them and execute it, it's like redundant. And then you cannot really use those test cases again. So redundancy of test cases, and then geographical distribution of users in an on-site offshore model, and then are some of the problems faced by organizations. And today, what is happening is most of the companies recognize TAS as a tool to deal with the, concerns, or to, cost reduction for managing a wide range of testing projects across a wide variety of platforms, and the pressure to resolve higher defect rates in a shorter time. Going ahead, a very typical structure from Wikipedia: cloud testing. So stress testing can be done, load and performance testing can be done, functional testing, latency testing, browser performance can be checked, compatibility across various platforms can be checked, and since this is on the cloud, it gives the advantage of, you don't have to be restricted to a geographical location, and the number of testers can also again be flexible and across the globe. The typical flow, if you look at it, you develop user scenarios, design test cases, and then select a service provider and set up the infrastructure, leverage the cloud servers, you start testing, monitor testing goals, and then you get the results. Some of the tools that are used here: HP LoadRunner, Advances, Cloud Assault, and SOST or SOSTA. What are the advantages here? There's a drastic cutback in infrastructure costs and immediate access to a range of testing scenarios, because this is, you have service providers, you just contact them and they would set up everything for you. So you don't have to go running around setting up the infrastructure, looking for resources or test cases. So, there's an immediate access, and there's a reduced time for resolving critical and non-critical defects. Again, because there's a wide range of testers and testing facility and infrastructure available. Disadvantages here: some applications cannot be tested on the cloud, data on the cloud, and some of them need hybrid, models to be tested, some of the applications. So that are some of the disadvantages. Crowdsourcing, that is another emerging trend, and that is catching up and becoming very popular. While application testing, crowdsourcing, or testing web applications, for example, crowdsourcing is becoming a very popular trend. What is crowdsourcing? Crowdsourcing is a combination of the words crowd and source, outsourcing. This was coined by Jeff Howey in June 2006. So he cites a typical example in Wired magazine, and he says a company, and I quote whatever story or example he has quoted here. For example, a company that needs to buy some stock photography. So what does the company or the organization do? The first option would be, of course, to do the photography itself, get photographers or get in-house for some photography, but insourcing would be expensive and the company may not be equipped for it to get high quality photographers or the equipment. The second option would be outsourcing. So what do? The company finds a photographer who's willing to take photographs and charges $100 a picture. The third option would be crowdsourcing. So what does the company do here? The company finds a stock photograph on the web. The cost would be, for example, $1 per picture. And so like there would be tons and tons of photography, websites or images available on the web. So the cost is going to reduce. And so, as Jeff Harvey quoted, there's a $1 solution to your $100 problem. And that is the power of crowdsourcing, which the organizations nowadays are recognizing and trying to leverage. A little more about crowdsourcing. So Jeff Harvey coined the term in 2006. There are 99 designs, which was the first crowdsourcing, design. Microburst is the fastest growing crowdsourcing. It is used in crowdsourcing is used in 200 countries worldwide. Obviously, there are totally, as we're going to count 1,755 crowdsourcing sites, 755 crowdsourcing sites available, a staggering $1.2 billion for projects, outsourced projects, and this is as recent as February 2002. So just an example of crowdsourcing. Outsourcing tasks to a group of people. A group of people are invited to test web applications or mobile applications. Here people can, freelance testers can just log on to the site and volunteer, or the service providers can specifically call or ask for testers. And what is the aim or the objective? Is to discover loopholes and suggest new ideas. Testing is carried out by a number of different testers from across different places. So it allows you, again, advantages of locales, regions, languages across the globe. Crowdsourced testing companies provide the platform for the testing cycles. They crowdsource the product to a community of testers who register for the testing services voluntarily, like I mentioned, some freelancing people who would like to do it. And testers are paid per bug depending on the type of the bug and its market price. So critical issues obviously get paid highly, not so critical issues down the line, and minor issues, of course, even less. The crowdsourced testing team is usually in addition to the organization's testing team, and it's not a complete replacement. So it's not as if the organizations want to replace their resources by a third party. No, a third party is just a support to the existing resources and infrastructure of an organization. The tools that are used, Innocent it's a very popular tool that is used for posting challenges and worldwide again, and a lot of people pick up the challenges and try to solve it, and there is money obviously involved, so monetary gain plus an intellectually challenging project to be done. So Innocent is a good crowdsourcing provider, and Top Coder is another one. Amazon, all of us have heard about Amazon. So one of their Amazon Mechanical Turk is one of the platforms. And UTest is another platform that, a crowdsourcing platform. Advantages, it is cost effective, as the product company pays only for the bugs reported, so they don't pay for the whole testing cycle as they normally would otherwise, and time to test the software is comparatively less. The reason could be that there are many testers testing across different functionalities, different domains, so there's a lot of cross-functional testing and the times are reduced. So it's not a single person trying to do this, then do that, across to get it done. So obviously the time is less. It leads to better productivity. Large number of testers testing a software simultaneously, as I mentioned. Testing can be done quickly, giving more time to market. So once you have a product, usually earlier what used to happen in the initial stages is you get the code written, try to do that and rush to do the testing done, make sure that your things are working. And then, sometimes your deadlines are kind of very close, or, you go over the deadlines. But now you have, testing that can be done quickly. So it gives you the advantage of, time to market. So you can improve upon that. And then the pool of testers is diverse with variations in languages and locales. So advantages of localization and internationalization, and which are based on localization. Coming to the disadvantages, security and confidentiality is an issue. When offering a project to a crowd for testing, it is exposed to a large number of internet users worldwide. And if the project is not released or is still under production or in the initial phases, then it's a very big risk, because a large number of users will and can discover its secret. And this inconsistent, so this obviously is not going to work for sensitive applications or applications that deal with security. The other problem is inconsistent quality and increased workload. The users that compose the crowd of testers are from different backgrounds, they speak different languages, they have different levels of experience. So what can happen is, you could have many poorly written bugs or duplicate bugs or erroneous bugs, or the, bugs not, documented properly. Going to the next one. Like we mentioned earlier in the previous testing, that if a system is under production, or for top security applications, data, how do you manage the data? Because this is everyone in the world and anyone in the world can test it. So, how do you take care of the data? You obviously don't want your actual real life data to be passed on to, everyone. So what do? So this has given rise to a new emerging field of test data management. So what is test data management? As the term suggests, it is managing the data for testing in a nutshell. So in a little bit of detail, it ensures the availability and security of the test data for large-scale testing projects. While testing an application, confidential information can get exposed to testers. So breach of this data can lead to serious damage, both to the brand as well as the business concerned. So vendors are now creating test-only data, which will help maintain the privacy and the security while using it. And it does not deal specifically with test cases. Thing to note here is it does not actually, give you actual test cases, but it deals with the data that you use for creating test cases and then executing them. The toughest part is finding the test data. So the data has to be in accordance with the application, but should not reveal, sensitive information. So that is the toughest part. The tools that are used, CompuWare, File, these are solutions. Grid Tools, a popular, organization that provides test data, and Solid Solution, another tool that can be used. The advantages: the data can be shared, the actual data is secure, and disadvantages: all data cannot be sanitized, and so hence, since it cannot be sanitized, it may not be suitable for very sensitive data. So that is the disadvantage. Security testing. Again, with the cloud and the net and web applications and a lot of data floating around, we have security testing that is emerging as a very popular, tool, and this trend is catching up. So what is security testing? The purpose of security testing is to discover the vulnerabilities of the web application. So the developers can remove the vulnerability or the glitch from the application and make the web application and data safe from unauthorized actions or people or hackers. What is the need for security testing? Lot of data is stored on the web, and sensitive data. Transactions are increasing, for example, net banking. Security testing is becoming necessary. Security testing is a process which determines that the confidential data stays confidential and data is not exposed to or handled by malicious sites or people. Going further, this is a typical flow. So for example, this is a normal user. This could be a hacker who enters, at the start posing as a normal user. This is done through the, password hacking. So log in as a user, hack the password, try to get in, and effortlessly that is done. The other point is here. So they can do, injections, SQL injections, or, crack the code, try to take advantage of the queries, SQL queries, or the sensitivity of the code, or the, the loopholes in the code to get into the application. Another view of security testing is you have data access, session management to think of, authentication, authorization, confidentiality, of course, server and code management, data validation, error handling, network security. For some of the tools for security testing, for Windows-based computers, there are 7 different types that are known. Port scanners, network or OS vulnerability scanners, application or database vulnerability scanners, password crackers, file searching tools, network analyzers, exploit tools. Some of the terms, okay, before we go here, security testing involves complex, it is obviously complex, and it involves typical terms which a tester has to know or should be familiar with. So let us look at some of the typical terms used. Vulnerability is a weakness in the system, and it can be either a virus, a bug, or an injection. We'll come to what is an injection a little later. Spoofing. What is spoofing? It is creating look-alike websites or emails. This is very typical for banking, net banking, or income tax sites. We often get full and phishing scams. So creating a look-alike of a bank site, for example, so the user can log in and then get all the data. URL manipulation, changing an information in the URL, which will cause a misbehavior in the server, and information can be extracted. XSS, cross-site scripting. That is, if a user inserts an HTML or a client-side script in the user interface of a web application, if this information is visible to the other users, it is XSS and not very, good, obviously, for the system or the application. What are the basics of security testing? The tester should have a good knowledge of the HTTP protocol. It is important to know how the client or the browser server communicate using this HTTP protocol. And the tester should also be familiar with the basics of SQL injections, SQL scripting, and XSS. How to do security testing? So password cracking, cross-site scripting, SQL injections, URL manipulation. Looking at password cracking, log into a website using a username and password, use a password cracker tool. Common username passwords are usually available with open source password cracker. And other sites which many of us are not aware of are the cookies that are inadvertently lying around. We don't clean them up, and hackers can easily see the cookies and extract information stored in the cookies. Password cracking, and then cross-site scripting. Any HTML script should not be accepted by the application. Hackers can use malicious scripts to get information stored in the cookies. The tester should be very careful not to modify any of these. What are they? The configuration of the application or the server should not be modified. The services running on the servers should not be touched. Existing user or customer data hosted by the application should not be handled. And really, a security test should not be done on a production system. It can really be very risky to do that. Security testing should be done much before that to make sure you've covered all your loopholes and then put it in a production environment. SQL injection attacks, they are very critical as the attacker can get vital information from the server databases, because SQL injections are meant to extract information from the databases, which are kind of the heart and soul of the application. To check the SQL injection entry points into the web application, how do you do? First, find out the code from the code base where direct SQL queries are executed on the database by accepting some user input. And then if the user input data is crafted into the SQL queries, then the attacker can inject the SQL statements or part of the SQL statement as user input to extract vital information from the database. And special characters should be handled or escaped properly, because if they are not, then again it can run into erroneous cycles, giving away critical information. URL manipulation through GET methods. This is one of the other methods. This is if an application uses an HTTP GET method, to get information. And also pass important information can be passed to the input variable passed by the application or web server. Can insert their own queries and then methods and get into the application. What are some tools for Windows applications, Windows-based applications? For security testing, you have application database scanners, password crackers, file searching tools, network analyzers, exploit tools. And tools for the other system, you have Linux, Mac, Wafiti for Windows, Linux, and Mac systems, Skipfish again for all three, Exploit Me again for all three. Coming to the conclusions now. So in a nutshell, we have seen different applications. We have seen mobile application testing, we have seen test-driven development, we have seen security testing by itself, and how to take care of the loopholes in the system or avoid loopholes through SQL queries or injections or special characters. And then we have looked at the cloud testing system and test data management by itself, how it can be, a very valuable tool for testing. And coming to the conclusions now. Software testing, going ahead. Like we saw, a lot is going to be tested. In one of the figures we saw that, there will be billions spent by 2015. Those are the projected figures. So software testing will need to build quality from the start to, curtail all the costs later on. Focus on developing clean code with less defects. Again, clean code, very vital to prevent, malicious entry into the system, as well as, preventing bugs later on in the system. Defects will be found earlier in the life cycle, like for example with TDD, where you do a stepwise thing. Your defects are going to be found earlier, so they'll be fixed earlier. It will require less overall effort to identify and resolve the issues as you go ahead. First of all, because the number of people testing are large, so you have a large variety of people you can, give your tasks to. And mainly because the way the system works, it's going to be foolproof or try to be foolproof. New security requirements, advanced technologies, new regulatory laws will require a new set of test knowledge for the testers or people who want to get into testing. Obviously, you have to know the terms, for example, and then the latest technologies and the latest tools. There are new tools coming up every day for different applications, so one has to be well versed in that tools. It's obviously not possible to know every possible tool under the sun, but we can concentrate on knowing what is it that we are interested in and what is it that is latest in our field of interest. So that would be important for testers. And new regulations, again, putting, new laws into place. So they have to be aware, or we have to be aware of the new regulations, the compliance requirements of the various governments. The cost of, one of the major plus points of all these new emerging technologies, of course, is that the cost of software will reduce considerably. Software testing per se will reduce considerably. So the whole cycle will cost less in general. So acknowledgements, various sources from the net, there are books, lectures, articles, talk to various people in the field. Thank you. Question and answers.
All right. Yeah. Thanks for the insightful presentation, Dr. Vimla Ravishankar. Let's quickly take up the questions now. You have the questions in your chat pane.
Okay.
Right? So you can take up the questions.
Yeah. I'll just the question here is, for TDD, do we need to know coding together with testing? The answer is yes, because it would help. I mean, because see, you have to write a test to satisfy a certain requirement. So I would say it would be very helpful. Of course, one can just write a test and then leave it to the developer and say, to begin with, that, okay, this is what I've done, this is the test, and then you can, execute this test and write the code. But in the long run, I would say coding would be very, very useful, because they do go hand in hand, coding and testing. Okay, there is a question here. How do you differentiate cloud testing and normal testing? Currently, I'm using cloud testing and do not see any difference. Difference would be in terms of the application per se. So cloud leverages the use of service providers, first of all, and then it is on the cloud or over the cloud. Normal applications within typically an organization may not leverage a service provider, for example, in the first case. There might be in-house testers doing it. So, and then of course, it is based on the application also. So for example, some applications are, not suitable for cloud testing. So in that case, you don't go to the cloud at all. So those would be the examples that, cloud-based has a larger number of testers involved, and it is outsourced, or it can be done by a third party, while normal testing per se can be done by an organization without outsourcing or without any third parties involved. I'm not talking about the techniques per se, because like we saw, cloud testing also involves stress testing and performance testing, and those would be the techniques within that would be the same. But the whole technology per se is different for cloud testing and normal testing. Yeah, is SaaS model already present in the industry? I would say yes. It, though may not be in all organizations across all industries, but SaaS is coming up in a major way and is being used by a lot of organizations. Okay, there's a question here, how crowdsourcing would reduce infrastructure costs. This is like we saw a typical example of Jeff Howey, that the organizations don't have to go scouting for it. There's a third party out there who's ready to do it at a lesser cost. So that is how it would, reduce the cost for the organization. That is, the organization does not necessarily have to set up an infrastructure for it. They can give it to a third party, and so the basic cost of setting an infrastructure itself would be less. What is the scope of automation in tasks? Again, things are coming up and tools are being developed to, automate things. So I would say automation not only in tasks, but all the other methods. For example, security testing or anything, automation would be a key concern. Even in TDD, you have automation tools that are coming up. So automation, I would say, is an inherent part of, or would become an inherent part of any methodology. Okay, there's a question here which says if the waterfall model is not good, then which model should an organization use? Waterfall model did work very well in the ESOP. There is one thing, and the Scrum methodology that is coming up. So Agile and Scrum are the two very popular things which I would say in a way may or are even replacing the waterfall model, and there are a lot of others which would come up in the future as well. Okay, it says, what is crowdsourcing? Please explain. So what is crowdsourcing is, for example, for typical mobile applications, you have people from all over the world testing the application. So you don't have, typically what happens in testing is an organization, within an organization, a group of testers or an SQA team does the testing. Crowdsourcing, as the term suggests, there's the crowd out there, on the net, over the cloud doing the testing for you, or on your behalf. So that is the crowdsourcing. That is, there are a lot of people across the globe, across the internet who do the testing for you. What is the difference between emulators and simulators? Emulator is typically a piece of hardware that is used for mobile testing. So you can hook it up to your system. So before the actual handset is made, you use this, as the term suggests, that it's something which will mimic or is similar to, but it's not exactly a mobile set. So it would act as a mobile set in that it would have the hardware in it as well as the software. So you can test it for the hardware and the software of the mobile functionality. A simulator would is a environment, or what can one say? It's a similar for the software that a mobile is going to have. Okay, how is performance and stress test conducted in mobile testing? I would say we use performance testing, for example, the call flows, or how many actions can you do and how does it crash. And it will also involve, like I said, the memory usage also. So performance and stress are related in a large way with the memory of the system. so how many simultaneous actions, for example, can you handle without, going into an overdrive or breaking the system? In terms there's a question here, what can we do for large applications? For example, for TDD. So I would say follow the Agile or the Scrum, probably. Or I'm not saying TDD is not exactly, impossible. It might be a little tedious because you do things in little bits and pieces, and it's a very huge application, then the time taken and the effort taken may be large. So in that case, you can follow the Agile or Scrum methodology to, hasten the work. And then here the question, can't we test database application? Yes, we can, but like whatever I talked about in the normal thing, it may not be possible. So you will have to, devise a different set of conditions or rules to do database testing per se. Okay, again a question, crowdsourcing helpful in IT world, please give an example or please give a scenario. I would say a typical scenario that I quoted again from Jeff Harvey is the simplest and the easiest thing that I can think of is like the organization would spend thousands of dollars, for example, for getting, some photography work done, while with crowdsourcing, that can be done, in a couple of dollars. So that would be the power of crowdsourcing. See, there's a question, we are paid on a bug basis, so regression testing is not included in this. I would say these are two different things. In the sense, paid per bug is the outsourced thing. Okay, the outsourced test, the organization would pay the third party for per bug, but regression testing would be done. And as I said, all these techniques are in addition to the organization's usually own, resources, QA or IT teams, testing teams. So the regression testing and the normal white box and black box testing still do exist. They are not going to vanish or disappear. They will be handled by the organization's own resources, while pay per bug would be handled, by the third parties. So these are two slightly different things. Can you throw some light on emerging trends on testing banking applications? I would say test data management, security testing would be prime. And some other areas, they would be prime for banking applications because data security is of prime importance. Security obviously an issue. You don't want hackers hacking into your passwords. So those are the two major things that would, which I can think of would be important for banking applications. Okay, is any injection testing tool available is a question. There should be. Personally, at the moment off the hand, I'm not able to give you an answer to that, but there are injection testing tools available out there. Yes. Okay, some open source, tools used for mobile testing. Again, some of them that I listed in the application, I'm sure would be available. And I'm not able to put an exact, there are definitely, open source tools available, and especially for mobile testing, with the rate at which, mobile handsets are appearing and the technology is changing. Which is the best automation testing tool? Well, you have QTP and then Rockies, but see, how is testing methodology different in agile projects? Are, the trends discussed vis-a-vis agile projects? I would say, this is not really project specific. It could be applied, of course, across, methodologies, and it wouldn't be specific only to agile would be my answer to that. Uh, Having an in-depth knowledge of coding, the user and user functionalities, which don't need, you could test the user perspectives, which don't need you to know coding. Is TAS only for cloud testing? The answer would be yes, because it is testing by itself, right? We are talking has testing tools used to test mobile apps. Again, I've listed a lot of them, and I can just quickly refresh them for you. Just a moment here, I'm just trying to go through the slides to see what are the tools that I mentioned here. Okay, tools for mobile application testing, you have Android SDK, you have Google Android, iPhone E, BlackBerry Simulator, iPad, W3C, some of them. out there, then any cloud-based, a service can be used, because usually a healthcare-based application is going to be a web application accessible over the net, so that can be used. And this is the last question I'll be taking, ladies and gentlemen, and how simulators sync with the hardware. The simulators don't sync with the hardware. The emulators are the one which, are used to kind of simulate the hardware and the software. Simulator is used only to test the software or test the code that runs. And then it is hooked onto a hardware device through a, mediators or typical connection. So thank you, ladies and gentlemen, for a very patient hearing, and I hope you all liked the session, and I hope it was informative for all of you. Thank you.
Thanks, Dr. Vimla Ravishankar, for your session on emerging trends in software testing 2012. It was indeed a great session. I would also like to thank all the participants for the support in making this webinar a success. The recording of the webinar will be available on techgig.com by tomorrow. Thank you all once again. Thank you, Dr. Ravishankar.
Thank you. Thank you very much. And thank you, ladies and gentlemen, once again.